Hello, my name is FAHMI CASTELLOW bin Hafiz. My matrix number is 74774. And today I'm introducing you to our group project. It's about manufacturing system of a brake disc. So before we start, I will introduce you our 5 awesome group members, including myself, FAHMI CASTELLOW bin Hafiz, DOROTHY bin FOONG, ALZAM, and Alex Man. The definition of manufacturing system manufacturing system are the different processes of transformation and production of a material or raw material throughout the use of tools, machinery, energy, and work. In manufacturing system, it is also include production of facilities like machine, manual workstation, automatic plants, material flow system, and so on, which are linked with each other for certain type of production as well. Support system, like the procedure of system, the management of production, the solve the technical and the logistic problem associated with the design of the product we want to make. It is also defined as a combination of all the action, the process used throughout the production, like the machine, a combination of all into one to make just one good product.
The first manufacturing system for the disc brake is manufacturing process and assembly. The brake discs were made using sand casting. If necessary, the casting patterns can be made from wood. The molds were made using a green molding technique that utilized locally available materials. The aluminum scraps were melted in a crucible furnace to make it casting material and then poured into the sand mold to form the brake disc. For quality control on the brake disc, the low pressure die casting LPTC system is used. This system allows for a homogeneous filling of the brake disc as well as a good thermal balance to achieve a gold solidification behavior. Next is basic disc shaping operations. Semi-automatic machining groups comprise of numerically controlled turning lathes and CNC drilling machines linked by transfer lines such as the VSC machine. A bin selecting cell is also used to load this system. Then the belts are used to move the braking disc to the VSC machine's workpiece shuttle. The first side of the brake disc is turned in operation 10, which is OP10, an advantage of vertical milling, in which the chips fall away downhill without hindrance, becomes apparent in this situation. Next is OP20. The procedure and necessary instruments are used to turn the second side once more. In OP30, drill heads on the driven tool turret drill the wheel bolt holes. Then, the final machining process, OP40, occurs after another in-process measurement for quality control. The brake disc cup is finished first, and then the friction ring surfaces are fine machined with NC lift of tool holders. This method ensures the required precision and surface quality. Finally, the second manufacturing system for the disc brake is the production machines. The production machines used here are semi-automated machines, which perform a portion of the work cycle under some form of program control and are joined to by a worker for the rest of the cycle. Loading and unloading parts are common worker tasks. A few workers would perform the molding process here before storing the product in the workpiece box. In the system, the automated part of the system will start once the workpieces are stored in the workpiece box and transported to the picking cell in the machine production line. The VSC machine is typically equipped with 4 machine arms connected by an EMAG track motion system. With these machines, users can modify the system at any time. For example, by switching out a machine from the process if not all the steps of the operations are required for a workpiece. Furthermore, FOONG can integrate several identical machines that perform the same operation in parallel into the chain. The track motion distributes the workpiece to the nearest available machine. In this case, tooling work on a machine does not imply downtime on the production line.
Hello, I'm Alec Anaman. Here I want to tell about the computer control system. The computer control system can be thought of as a way for a digital computer to manage a manufacturing process. A computer is used to run the automatic system, and computer process control is specifically relevant to continuous or semi-continuous operation. There are three computer control systems used for brake disc manufacturing. One of it is computer aided design, or we call it CAD. CAD is used a computer to assist in the correction, modification, analysis, or automation of the design. This program is used to increase design efficiency, design quality, and create database for manufacturing. Second, we use warehouse management system, or we call it WMS. The WMS is a set of producer and guidelines that are frequently used in assembly line to improve logistic efficiency. WMS intensive inventory manage capability, including barcode, stock count, and batch number to keep track of the brake disc. Last, we use programmable logic control, or we call it PLC. PLC is a robot device that monitor, communicate, and execute command placed into it by an operator to carry out the machine intense function.
For the human resources, two operators will melt aluminium scraps from the melting deck station in a crucible furnace using two machines. Like at the melting deck, at LPDC cell requires two operators and two machines to enter the proper data and automatically handle calls. Three operators watch the molding progress on a monitor, while three machines count the quantity of brake discs carried into the molding area. And quality control in the finishing area requires three operators and one machine to transfer the brake disc from the LPDC cell. At storage, two persons store quality controls brake disc in a workpiece box. At VSC machine, two persons monitor data in production while two machines spin, drill, mill, and grind. 6 operators will monitor cell parameters during end-of-line testing. 2 persons per machine will test cell performance and identify mechanical property race. Return to storage, 1 operator will monitor the conveyor belt status, and 3 machines will load the brake disc from the conveyor belt to storage and record the total number of ready-to-use brake discs. So for the material transport, gantry robotic arms, roller conveyors, pallets, and forklifts are used to carry the material.
Hi, my name is Dorothy with matrix number of 74626, and I'm gonna tell you about our storage and identification system. So as we all know, the storage and identification systems are two very much important components of the manufacturing system. Storage system allows us to organize our materials and also allow the workforce to access them easily. So the one that we have chosen is pallet racking system, with loads placed on top of double dip pallet racking, where this allow us to know the location of our product, which is brake disc. And then the next one is our identification system, which will be a barcode system scanning system. So here, once you have scanned the barcodes, it will tell you the details of the product, the technical specification for the product, and as well as the location of the product store. Okay, so this shows that time and energy will be consumed efficiently by using pallet racking system and as well as barcode scanning system.
So this is the layout of the brake disc. As you can see, there's a drawback filter, friction bell, friction surface, cooling channels, and identification. And this is the layout for the plant.